All right, let's look at the probability of getting at least one of an event occurring from n number of trials. So to do this, we're going to be using this equation. And so the probability of getting at least one of an event occurring successfully, we need to use the complement of that, which is going to be the probability of failure in one trial to the nth power, or the number of trials. So the failure in one trial is equal to the complement of successfully getting at least one success of that event. So let's try and learn this concept through some examples. So in this example, we're looking at the probability of youth soccer players in a residential community. So 2% of children in a residential community play youth soccer. If 8 children are randomly chosen from the residential community, what is the probability that at least one of the 8 children plays youth soccer? So this is going to be our number of trials, the number of children, but we want to know what's the probability of getting at least one of them playing soccer if we chose 8. Now we know what the probability is of just choosing one. That's 20%. But what if you chose 8 children and you only wanted at least one of them to play soccer? What's that probability? So here's that initial equation that we have. Okay, this is what we're looking for. So what we need right now is we need to find the complement of at least one. We need to find the probability of failure in one trial. And so the probability of failure is 1 minus the probability of success. And so that's going to be 1 minus the probability that of randomly choosing a youth soccer player. And we already know what that is. That's 2%. So we're going to substitute 0.02 for the probability of randomly choosing a youth soccer player. So that's going to be 1 minus 0.02. So 1 minus 0.02 is 0.98. And that's our probability of failing to choose one child who plays soccer. Now, this probability of failure of one event is what we're looking for here. And now we're choosing 8 children, so that'll become our exponent here. So when we substitute the probability of failure, which is 0.98, and we substitute 8 for n as an exponent to 0.98, and the probability of at least one is going to be 1 minus 0.850763. And 1 minus that is going to be 0.1492, or 14.92%. So if we were to choose just one child from the community, we would have a 2% chance of that child being a soccer player. But we could increase our chances of choosing one child that played soccer if we chose more than one. So if we had chosen randomly 8 children from this community, there's a almost 15% chance that one of those 8, at least one of those 8, will be a soccer player. And that's better than 2%. All right, let's look at the next example. So what's the probability of getting at least 1 6 with 3 die rolls? So what we need to look at here is the probability of getting at least 1 6. And we need to figure out what the complement of that is. Well, the complement is getting exactly 0 6s. And so what's the probability of not getting a 6? Well, that's going to be 5/6. because five, you have one, two, three, four, and five. Those are all outcomes of a six-sided die that aren't six. And it's going to be out of three die rolls. So that's going to be the third power. And using the properties of exponents here, we can apply this exponent to the numerator and denominator. And so 5 to the third is 125, and 6 to the third is 216. And 1 minus this fraction of 125 over 216 gives us 0.42129, or 42.13%, roughly. All right, I don't have any think, pair, share problems to follow this, just these two examples. But what I do have is, if you're looking at the PDF of these lecture notes, please notice that at the very top, I've got these two links. I've embedded these two links. If you're looking at this as a PDF, you can just probably click on it or tap on it, and it's going to open a web page. Okay. Since I'm in Microsoft Word, I have to hold down the control key. I don't think you'll have to do this holding down the control key, but if you just tap on the link, it's going to open up a problem in MyOpenMath that is, an example, another example, but this is like a think, pair, share, where you can actually try and calculate the probability yourself, and it'll tell you whether you have the correct answer or not. And you can keep doing this, practicing it over and over and over again. If you keep clicking, try a similar question, it'll change the numbers up above. Okay, and it's actually changing some of the questions down below. Okay, so if you want to keep practicing, you can do that. The other link is very similar. This one here. This one, looks exactly at a problem that's only at least one. So, you can keep trying this over and over and over again. You can see it's changing the color of the M&M. They're on the right. And it's also changing the probabilities up above. Each time you put try similar question, and to check your question, just type it in and click submit. Okay. Let me know if you have any questions.